So hello and a warm welcome to our webinar. I think it's time for us now to kick off this webinar and for me to introduce today's moderator, Mr. Jim McHale. Welcome, Jim, as the moderator. Here he comes.
Great, thank you very much, and welcome everybody. Fantastic to have you here. And of course, today we're talking about a really important topic, a major harmonization effort between these two smart building metadata standards, Brick Schema and RealEstateCore. And let's get started. So I'll just go through the agenda for this webinar today, and then also a little bit of housekeeping, and then I'm obviously going to introduce all the people that are on the call. So as I said, we're going to introduce the participants. Then after that, we're going to look at the background and motives of the corporation, and then a walkthrough of how Brick and RealEstateCore work together right now, and then some insight into the roadmap of the standards. And then finally, we'll be doing a Q&A. So just before we start, like a little bit of housekeeping around that. Be great. I mean, really like people to ask questions. And again, when I introduce people in a minute, then you'll be able to see if you want to ask people specific questions, feel free to do that. You'll see on the panel, on the GoToWebinar panel, there is a section saying questions. You can type your questions in and I will get them, and then I'll be able to put them to our to the team that are on the call. Also, it's only you and myself that can see those questions, so you don't need to worry about other people seeing them. And finally, we are recording this webinar, and it will be available on both the RealEstateCore and Brick Schema websites at some point soon. Yeah, so again, like I really hope that if you enjoy the content today, please share it with colleagues and point in the direction of the recording when it's available. So let's make some introductions. You've already met me. I run a company called Memory Research, and I'm just providing the role of moderator today. But the really important people are first Dr. Gabe Fierro, who's going to represent the Brick Consortium. Gabe, do you want to join us on the line now?
Hi, yes.
Hey, Gabe. Also, Dr. Carl Hammer, who will be representing the RealEstateCore Consortium. Hi, Carl. Do you want to join us as well? Hi. And then also on the line, but not presenting today, will be Joel Bender from ASHRAE 223P, Dr. Eric Paulson from Johnson Controls and the Brick Consortium, Alina Stangiu, I hope I pronounced that right, from Microsoft, and Dr. Eric Willing from the RealEstateCore Consortium and IDUM PropTech. So if anyone has questions for them, again, if you put those in the chat, they'll be able to take them in the section at the end. So just a little bit of, I just want to set the scene quickly. Obviously, we're talking about this major harmonization between the two standards. And I think this is a really important issue for many reasons. I think currently what we see at scale digital transformation in the building industry, the real estate industry, is really challenging because there are a number of competing smart building metadata standards. And indeed, some of these standards often do have some significant overlap in features. And what we've seen, I think, over the past few years is RealEstateCore and Brick Schema cooperating to create some alignments. But brilliantly, today, and what the guys are going to be announcing is that over the past 6 months, those efforts have really ramped up. And there's been some extensive work carried out to actually harmonize these two projects. And hopefully that's going to result in a new clarified metadata solution, removing the need to choose between either Brick or RealEstateCore. So I think I'm going to hand over now to it's Gabe and Carl who are going to take you through the presentation. Hi guys, take it away.
So I guess I can start here. We're going to give you, dive right in to how exactly we're going to be accomplishing this. And like Jim said, the intent here, many of these standards started off with a particular vision and a particular scope, and over time, as the understanding of the problem evolves, you slowly creep into other domains, and that's what Brick did, and you see that with RealEstateCore as well. And so what we're really trying to do with the harmonization, and what we have done, is to make clearer semantic boundaries between the two. It's no longer trying to remove the confusion of when am I going to use this class or when I'm going to use this class. They seem very similar. So eliminate these overlaps and rather move the standards to a point where they are complementing each other in terms of the domains that they cover and the concepts that they model, rather than promoting competing concepts. So you can think of the major change here being that essentially Brick is going to take on the equipment modeling. So the ICT equipment concept classes that exist under RealEstateCore, some of those will move over into Brick. A lot of those equipment classes will move over into Brick. And likewise, Brick will be relinquishing a lot of the location classes, which we also stole a little bit from RealEstateCore, and making sure that those concepts are well defined under the RealEstateCore ontology. Similar things with the RealEstateCore collections, similar things with a few other tidbits here and there, and largely unchanged are going to be the bulk of the rest of those ontologies: Brick points, RealEstateCore agents and building elements and entity properties in Brick, and that assortment of things. And on the next slide, it's also important not just to clarify how the classes or the classes in each of these ontologies relate to one another, but also how those classes or instances of those classes can be used inside the models themselves. And so there are associated sets of property changes, and recall the properties are essentially the relationships between the instances and the entities in each of these models. And so the refined set of properties, and we've updated the semantics in each of these models to ensure that you can essentially use classes from Brick and classes from RealEstateCore together in these sort of fixed set of broad relationships that are mostly used for these building metadata models. And this is for two ends. First of all, it means that I can use Brick and RealEstateCore together in my model of my building without having to worry about some piece of software complaining that needs to be a Brick location and it's a RealEstateCore location, so you did it wrong. So all of that is now subsumed. This will also allow us to facilitate migration of any existing models, and that it's not necessarily the case in this initial step that all of that's going to be invalidated, but that there's a little bit of flexibility in how those properties are used, with a clear path towards the harmonization as we all move past this world where everything's separate and towards one where we do have a unified collection of ontologies with clear semantic boundaries. I don't know if there's anything you want to add to this, Carl, or?
Yeah, it sounds just like everything we've spoken of and worked on. I could add that the Brick points are also going to be used in RealEstateCore instead of what we up until last version called RealEstateCore capabilities, which were essentially modeling the same thing, and there we're taking on the Brick points instead, which are a more established standard for how to express those things.
Thank you. On the next slide, we want to talk a little bit about the where we are in Brick on this, and there'll be more on the roadmap later on, but the Brick 1.3.0 release is pending. We're probably about a month out from that. It's not going to contain these changes yet because of our the approval process has been slow on our end. So Brick 1.3.1 or possibly 1.4 coming in the next year will contain the formal set of all of these changes. And in the meantime, there will be essentially a little shim, a little piece of a graph that you can insert into your database or your model that will take care of these translations and these changes for you. And so one of the big changes in Brick 1.3 is that we're moving away from the OWL ontology language and towards the SHACL validation language. This is for a number of reasons. First off, validation of models turns out to be very important, and there are existing standards for that, and so we're ensuring that our future work is aligned with the current W3C standards for how to perform validation of RDF models. Second of all, this makes it much easier to enforce and capture the actual semantics of using Brick and RealEstateCore together. We can get into the weeds during the Q&A if we want to, of how the description logic approach towards modeling sometimes makes it difficult to deal with. It could be this or it could be this, but not that other thing. So this is just much cleaner to model this harmonization in SHACL. And further, because the pending ASHRAE 223P standard is also based on SHACL, this also lays the groundwork to ensure that Brick and RealEstateCore will be able to work with the ASHRAE 223P standard when that is released. All right, go ahead on the next slide.
Yeah, so, and I should say also that Brick moving toward SHACL marries very well with what we in RealEstateCore also were doing in parallel, because we also had realized the same, shall we say, constraints or challenges in using OWL for modeling this domain, and in particular for users and customers to deploy solutions based on OWL. So we were also moving towards SHACL, and as things happen, we made a good connection there and figured out we should move towards SHACL together, perhaps. Now, I won't be talking so much about the SHACL aspect as Gabe did, because I'll be covering RealEstateCore 4, which is due out, well, today essentially in a preview version, just now on GitHub. And as this picture shows, what we have there is that RealEstateCore 4 includes Brick. This is a folder directory just for my computer, of course. And what we have down on the bottom there, we have the SHACL models of RealEstateCore and Brick. And the idea is that by importing them into one set of SHACL or into one model, you can query across them, and I'll show you a little bit about that. We also, in RealEstateCore 4, actually are releasing DTDL models as part of the RealEstateCore release. And DTDL is the digital twin definition language, which is used in, among other things, the Microsoft Azure Digital Twins platform. So that's also a benefit of this work from our point of view, is not only can we collaborate with Brick on the SHACL side, but we can also translate Brick into DTDL, which is something that some customers and users have requested for some time. So this is also an advantage for both projects. And we could move to the next slide. And just briefly how we do that translation, because DTDL is an interesting and upcoming standard for how to model this domain. We translate node shapes from SHACL into what's called DTDL interfaces. That's roughly comparable to an OWL class or a concept, if you will. We translate SHACL property shapes. Those are the restrictions on what outgoing edges are allowed from a certain class or instances of a certain class. We translate those into what's called DTDL properties in the case of data fields, or relationships in the case of relationships to other nodes. We translate labels, RDFS labels, into display names in DTDL and comments into DTDL descriptions. And these are all fairly natural translations. And then we translate the identifiers because the DTDL language uses URNs instead of URIs. And we do that translation in a structured manner, as indicated on the screen here. There are some meta model, shall we say, there's some disjointness in the meta model here, in that the DTDL model is a property graph model, So you can express properties on edges, which is not something you can do in RDF and SHACL at the moment. Though I just heard that the RDF star working group is been chartered by the W3C, so they hopefully will resolve this in the not too distant future. And DTDL uses locally defined fields, whereas SHACL and RDF and OWL also uses globally defined URIs for well, edge names. So there's a bit of mismatch there, but we've been able to resolve most of that through simple practices. And so we now have tooling to do this translation from SHACL to DTDL, and in the near term, the other way, also from DTDL to SHACL, to maintain this alignment between the RealEstateCore ontologies and the Brick ontologies in both languages. So next slide, please. So this is an example. I mean, this is the Azure Digital Twins platform, but it might as well be the SPARQL query language across a SHACL models and triple store. This example is the DTDL version. And it's a bit dark to see here, but essentially this graph describes a small scale building that has a lower floor and an upper floor, and each floor contains only one room. It's a toy example. And I want to be able to query for getting the last known values of temperature readings in those rooms. And in this model, you'll note that towards the bottom there is a query. You'll note that the room is defined using a RealEstateCore URN, whereas the model of the sensor is described using a temperature sensor from Brick. And this just works fluently, no problem at all, importing all of these and instantiating them and creating graphs and querying across those graphs and generating the output on the right-hand side. And this is actually one of those new things in Brick that came out of this collaboration also that I'm very grateful for, is that we now can express last known values on points in Brick. Both the value and a timestamp for when that value was either detected, if it's a sensor, or when the payload was sent, if it is a command, or set point was set, if it's a set point. So this is also something that came out of this collaboration because we had a need on the RealEstateCore side to be able to display the right now state of all the sensors, including their values. So thank you, Gabe, and the Brick team for letting us have that, and I hope it'll help you out on your side as well. So I think, and again, this might as well have been SPARQL queries. Conceptually, it's the same thing. We can now query across the spatial model and the point model and the equipment model if we were so inclined. And we could even bring in from RealEstateCore tenants and leases and whatnot and post queries like give me all of the air conditioning units that affect rooms that are within leases that expire in 2 weeks or what have you. I mean, I don't know why you would want to do exactly that, but queries of that nature, which go beyond just the equipment and just the points and just the spatial model, but allow you to query your entire smart building graph. Right, next slide, I think. Right, so Gabe, what's up next with Brick?
Yes, so we are planning on moving forward with directions that hopefully complement the RealEstateCore collaboration, as well as help to unify the broader space of building metadata, which has been growing over the past few years. So, of course, in the future of Brick, we're going to incorporate all of these integration changes into a formal release. We are also looking at expanding the class hierarchy of concepts, looking at security and safety subsystems, hopefully arriving at a decent model of heat pumps and chillers. Every time we dig into this, turns out there is just more variation and more properties that people want to know. But there are active conversations in the Brick community on how to do this. And if you have opinions about heat pumps, you work with heat pumps, for any of these, we would absolutely welcome any sort of contribution or feedback on that design as it emerges. We're also looking at incorporating more of the ICT equipment, borrowing primarily from the existing RealEstateCore concepts. One of the things we've also been modeling in Brick are these standard properties. So these are primarily static characteristics of equipment that might be delivered from a nameplate, might be derived from some sort of analysis, such as a coefficient of performance or measured power delivered rather than rated power delivered. So we are looking to grow that set of concepts to ensure that there are standard models of these static attributes that can be queried from the model and related to different pieces of equipment. One of the other pieces that we have been developing is what we're calling a ref schema. One of the big integration issues in buildings is dealing with the variety of protocols and existing digital representations that are out there and may exist in any combination and to any degree of quality. And so rather than attempting to basically eat the world and model every single concept and every other digital representation, we're trying to move these metadata graphs towards a point where they can complement those existing investments rather than invalidating them. And so we are working on a standardized set of foreign keys, essentially, into IFC models or BACnet networks or SQL databases that store data. This is something that I think complements very nicely with the telemetry support that's built into the digital twin platform, but it also means that we can refer to an object in an IFC model or refer to an object in a BACnet network without having to pull out all of that metadata and represent that in an RDF model. We're also looking at improving the set of tooling. RDF has an opinionated set of tools primarily developed by ontologists. And so as part of our operationalization of RDF, we've been looking at trying to provide tools that meet software developers that may not have an ontology or RDF background halfway or maybe a little bit further towards the software engineers. So of these, we've been working on application-driven model authoring tools. A big question is, if I'm going to go model my building, how do I know when I'm done? How do I know when I'm finished? How do I know when I have the amount of information in that model required to actually run the applications that I want to run? And so we have some work funded partially by the Department of Energy that should be open sourced hopefully within the calendar year. Also looking at other solutions for storing different models of buildings over time and being able to check out old snapshots. And it looks like the last bullet got cut off a little bit, which is unfortunate, but one of our big thrusts of development is integration and harmonization with other efforts in this space. So ASHRAE 223P, which will be a RDF SHACL-based model that models the topology and composition of these systems at a much finer degree of detail than either Brick or RealEstateCore is really looking at right now. And eventually, those are the kinds of models that you would hope to be embedded on your controller when you go and buy a piece of equipment. There is also a Department of Energy funded project to harmonize Brick with Project Haystack. And so the Brick team is working actively with the Project Haystack development team to figure out a way that those two models can move closer together. And so there are, perhaps alternate representations of the same model, or, maybe tags sit on top of the RDF model, or some form of harmonization. It is active work, but please look out for future information on those lines. I think that's it for this slide.
Thanks, Gabe. And I mean, that sounds super interesting also from a RealEstateCore perspective, because one of the reasons from our point of view of this collaboration not only is to gain greater outreach and greater usability of our models in industry, but also, to be honest, to reduce our maintenance burden on those hierarchies of the model where, you know, you guys are focusing. And so if you do a lot of work there, we'll be happy to continue to take that. Very much appreciated. On the real estate core side, we just now today released a preview release of RealEstateCore 4, which includes this, as I mentioned. And initially, our plan was actually to do the full release today or at this point, but we recognize that this has been a bit of a sort of skunkworks collaboration over some time, and it's probably better for the broader community to release a preview version and then have, you know, a number of months now to elicit feedback on what you guys think of this and what may need to be adapted before a final general availability release later this fall. And that's a long-winded way of saying that we don't actually have an established feature roadmap post 4.0 because we've been so focused on 4.0, which was releasing now. So what we have on the screen here are a couple of things that we do think we do need to do longer term. So translation mechanisms, we've noticed that while the difficult thing in modeling ontology is not actually the serialization, is not actually the models themselves, it's the conceptualization and the gathering of data and the requirements and figuring out how to model something. And thereafter, I mean, as long as you can draw a node edge node diagram, you can use SHACL or DTDL or ER models or what have you to properly serialize that into some system at some point. And we've noticed that users have a very wide variety of systems that and standards that their systems require. So translation mechanisms for translating these models in a way that makes sense between these different formalisms is something that is high on our agenda. And obviously DTDL and SHACL are the first ones, but also we do generate our API definitions and open API definitions in Swagger directly from the models. So essentially classes or interfaces become RESTful endpoints with HTTP verbs on them that can get JSON LD objects out. And we would love to probably add more translation mechanisms to whatever formalisms users need and require. Another tooling aspect here that we think is sorely lacking and where we hope to develop some work is editor support. Because we can't expect ontologists or ontology users necessarily to be, well, we can't expect users to be ontologists rather. And so at the moment, the market of editing tools for SHACL and for DTDL is very limited. And so if we can provide support in that space, building tooling that allows you to add your own customizations and additions, that's something that I think is important. And finally, solution accelerators there in terms of tooling. So we do not only need the models and the APIs, we should probably also, for broader adoption, provide software components that do something that is useful. And even if it's only proof of concept and small scale, but still something that is turnkey that we can put in the hands of devs and for that matter of CIOs to show that this is something that actually works and you don't have to build it all yourself, or if you are building it yourself, there's these things you can look at to see how people have solved similar issues before. So these are things that I think we do need to look more into on the RealEstateCore side. And then of course we have aligning with and reusing other ontologies and covering more domains. So the business side of it, definitely we do have at the moment, we have the notion of leasing and leases and that part of it, but business goes much further than that, of course. Energy and energy optimization and energy utilization is something that goes beyond just describing the energy sensors and points, but actually describing processes perhaps and energy utilization of those processes and which equipment those processes involve and so forth. So that's something that's certainly worth looking into. And then we've had requests from industry regarding waste management and recycling aspects, which is also something where we think there's at the intersection there of, shall we say, ownership and facility management and spatial, and to some degree also equipment. There's the waste dimension can probably bring value, provided we get some of those solution accelerators relating to waste representation and waste utilization. So those are things that are on the sort of the tentative roadmap. I would like to add also that if you, the viewers of this screencast, would like some additional domains to be covered or included, this is a community project, and we are super open to taking such input and requests. So check out our dev site and the community link there for how to get in touch and do things with us. We are happy to take a discussion on missing features. I think that's all for this slide. And we're already here. Jim.
Yes, indeed. Sorry, I'm coming back. There we go. Great, thanks, guys. That was a really good overview of what's been going on and also where you want to go with this. So we have had quite a few questions come in, so we can start getting towards those. And I'm guessing that we have some other people on the line as well. So if they want to contribute an answer to a question, then they can just come online. Yeah, let's do it that way. So I'll just take these questions as they came in. First one, will the two-way relationship exist in both RealEstateCore and Brick? Is that one for either Gabe or Carl, I guess?
So I'm guessing the two-way relationship refers to inverse properties, so feeds and is fed by, and has point and is point of. And if that's what you're referring to, the answer is yes, those should both exist. And I think we have equivalency defined both ways in the current patch. Is that right, Carl?
I'm not 100% sure on that, but I mean, equivalency being bidirectional should be enough to go one way, I would imagine.
Yeah, fine, yes.
But my take on the question was, and I may have misinterpreted, was slightly other. I mean, will they work both ways? So, RealEstateCore 4 includes Brick as models in the RealEstateCore distribution, which works because Brick is BSD licensed, and we are from Rec 4 going BSD licensed as well. So essentially, if you're downloading and running RealEstateCore, you're also running Brick. I don't know whether Gabe, you're looking into doing something, well, whether you will package in the same way, specifically when you get to your 1.3.1 or 1.4.0 version, but hopefully it'll work that way as well.
That's our intent, yes.
Yeah. Cool. Okay, guys, next question. This unified Brick RealEstateCore effort, will it be available in DTDL?
Yeah, and it is available as a preview release today in the RealEstateCore GitHub repository. So that's RealEstateCore 4 contains, on the top level you have top directory structure, you have ontology. Beneath that you have DTDL and SHACL. And both of those subdirectories in turn contain Brick and RealEstateCore subdirectories. So yeah, we have Brick as DTDL and as SHACL, and we have RealEstateCore as DTDL and as SHACL within sort of the distribution, in addition to the API definitions and some other stuff and the documentation.
Okay, great. Nice question from a newcomer. So is DTDL used by non-Microsoft cloud companies? And he said Amazon, Google, because I guess you used the example of Microsoft Azure there.
Yeah, I'm actually going to punt that question to perhaps Alina. Do you know of any other applications of DTDL?
Is Alina there? Maybe not. but we can come back to that one.
But I do not know at this time of any deployments of DTDL in non-Azure based platforms. But the DTDL language spec is publicly available and it's implementable by whoever like, oh, here's Alina.
Yeah, I'm sorry, a little bit late, but yes, I'm here. You are absolutely correct, Carl. So currently DTDL is used only in the Microsoft products, yes, Azure Digital Twins and other services like IoT Hub. So currently only Azure products.
Okay, thank you for clearing that one up. Okay, this is I guess a very kind of a specific question, but maybe we can take this and see. Is there a data structure for real-time, near real-time data exchange for energy meters? And it says we have a green button from the US, Brick, etc., but there are not real-time, real in inverted commas. Azure DTDL API has a telemetry class. Any thoughts?
I would say that the real-time aspect or not is orthogonal to the data modeling aspect. I mean, that's a platform implementation and design matter, whereas RealEstateCore and Brick are about how to model your building graph and current state then of those sensors, but whether those sensor values are ingested real time or close to real time or at a later time. I mean, we do have the last known value field has a timestamp on it, so you know when it was the point was created or the value was set or sensed rather. But again, that's an orthogonal matter. So you're going to have to see what tech stack you're building on to whether that can support real-time or near real-time updates of your graph. And I would say most often those telemetries go into a time series database anyway, which is not the graph, but something else for time series analysis.
See, Eric is doing this. Did you want to make a comment, Eric?
Yeah, though I would defer to Gabe if Gabe wants to chime in here, but I could chime in as well.
Go ahead, Eric. Yeah.
Okay. Well, I think this is actually one of the next needs of some of these metadata standards is being able to get into the actual information exchange. If you look at to borrow a quote from the Blues Brothers movies, sometimes it feels like BACNet's got both kinds of data, real and Boolean, and so you don't have to worry about how to, what do the bits on the wire look like for exchanging real-time data, because there's only two, it's generally pretty obvious. But now we're into sort of a world where the sensors are getting richer and are exchanging kind of fatter messages. So you look at a lot of these more standalone sensors that might be devices that have their own IP address, and they sit there and you connect them to some kind of MQTT stream to exchange data. The actual message that's getting exchanged, that's all over the place, right? We know what that looks like. Usually it's some kind of blob of JSON, but so in order to read it, you got to know kind of roughly what's the schema of the JSON being used, but it might not even be JSON. It might be some other might be a blob of protobuf or something else, some other kind of encoded sort of thing. So I think this is an interesting question about either standards, and Brick and RealEstateCore kind of have we model the slower changing things pretty well, and then we give you pointers to where would you find the faster changing things, but what that format of the messages that might be going back and forth across that is, that's a little up in the air. There are standards in the IT world. The cloud event standards defines a message envelope, but it doesn't actually usually define message payloads. And I think there might be some space for message payloads to tackle some of this. So what would if you're getting smart meter data on 15-minute intervals from different smart meters, what is the representation of that? That may be in a domain. The smart meter people may have something defined for that, but we don't have kind of those connections made across the world yet to really define that. But I think that's a important part of how we may want to move forward.
Yeah, great. Thanks, Eric. Anything to add, Gabe?
No, I think that covered just about all of it. I mean, when you talk about real-time data, that real-time is a very sort of fuzzy concept, because there is necessary latency, right, in order for that information to get to any point where I can read it. So the fact that there is a last known value that has a timestamp is incredibly important, because it allows you to reason about how old that data might be. And I think eventually, you know, as these other real-time standards emerge, it is our role and our where we can really help is in providing context for where that data comes from. If that's I can't remember, there's whatever the smart grid reporting standard is, C37 or C137 or something like that, or if that's MQTT, or if that's Web of Things, or if that's BACMed or Modbus or whatever that transport happens to be. The role of Brick and RealEstateCore is to provide context there. So I think whatever those innovations may be, that's something that we can integrate with. And certainly if you have a specific need or a specific protocol, reach out to, you know, Brick or RealEstateCore, and we are always happy to be driven by the needs of the users in the communities.
Yeah.
Actually, there's one thing that I thought about now when Eric spoke, and I had a bit of an audio issue, so I hope I didn't miss anything. But if we're now talking also about the payloads of those, the semantics of those payloads, and the provenance of those payloads, then it's not too far-fetched to start talking about the provenance also of analytical points, if you will, or points that don't come from a real sensor, but that come from some process, and the provenance of that, and to be able to provide traceability and trustworthiness of things like well, quality assurance processes and certification processes and whatnot. So, and there's definitely a business case for doing that, I think.
Well, you've teed me up very nicely for the next question. So thanks for that. This is because I think this is super interesting. Is what is the group view? So, you know, anyone who has an opinion, please come in, on integrating simulated data to a model. Should the user have asset model with data coming from real sensors and a simulated model with data coming from virtual sensors? Or should we have a unified model with virtual properties and real properties?
Well, I mean, this is not something that one wants to just pick up like intuitively and say something about, but I'm going to do that anyway. I think the power of querying across the graph that's a very powerful feature, to be able to query across heterogeneous graph. And if you have two different models, one which is sort of simulated and one which is real, then I think you may risk losing some of those queries that you may want to post at the intersection of that space. And I think it's quite possible to have in place a generic meta model saying, you know, this is the provenance of this data, or this virtual sensor is actually tied to this particular process, whether it is some aggregation or some machine learning model or what have you, so that you can query directly in your graph all the way from the real source data that was transformed through some process and analyzed through some process to the synthetic point that is emitted as a result of that process. Of course, if you're not dealing with entirely synthetic, completely disconnected data, that's, I suppose, is a different matter. But I would say something like that is, we made some attempts at that in earlier versions of RealEstateCore, but it was very shallow and wasn't used very much, so it's not currently in the model to have that support, but certainly something to consider.
The thing that I would add to that, so I think that's great. I think I agree with the majority of that. When you are dealing with So the idea of a virtual point, of either something that is a, usually I take that to mean some sort of computed quantity that is the result of synthesizing or computing over a set of other virtual or I guess physical data streams. I should point the interested individual to the control description language. So a long story short, there's an effort begun by folks at Lawrence Berkeley National Lab, among others, that is now being worked on through a pending ASHRAE standard 231P. So keep that number straight, where the intent is a vendor agnostic specification of control sequences. And if you have a control description language, say implementation of a sequence of operations or a fault detection rule, you could compile that into whatever vendor specific or proprietary or embedded programming language that would actually go and run in your controller somewhere. And what that means is, if I have a structured representation of that logic, then I can essentially begin to ask my model questions about how is this temperature sensor used? Or where does this virtual metering point come from? What is the computation by which you are estimating the power used for cooling in my chiller plant or something like that? So there are steps being taken along in that direction of being able to model the computational provenance of a current value and modeling controllers and analytics and other transformations in a standard way. And it is likely, though I don't know how much that is in the scope, it is likely that some of that will be expressible as an RDF model. And in fact, that's one of the things that the ASHRAE 223P group is working on right now, is ensuring that those concepts, and by virtue of, if it works with 223P, eventually it will work with Brick and RealEstateCore, because that is the vision, that I could refer to a Brick concept or a RealEstateCore concept in a standard description of my control language.
Okay, thank you very much. I hope that answered your question. Now, so thank you, Gabe and Carl, for the presentation. It has been touched on, but could you elaborate on when we could expect a tool to edit the ontology in its DTDL format, and how to approach it to the point that such a tool, or to approach it now until the point when such a tool exists?
Yeah, so I would say the tool support that exists right now for DTDL is there's a plugin for the Visual Studio Code environment, which allows you to write models and ensure that they follow spec. The gaps are, I think, in terms of visualization. There's some visualization built into the Azure Digital Twins platform through the ADT Explorer. But that is still rather rudimentary, I would say. So for model exploration and checking it out, I would actually suggest something I built myself the other week, which is DTDL to Markdown translator, which is available on the RealEstateCore dev site, which takes as input DTDL models and emits Markdown-based documentation, a little bit like Javadoc, but for DTDL models. That allows you to navigate your models and those properties and those relations. So then you have the editing in Visual Studio Code, and you have sort of the viewing of the models there. I still think some sort of tooling, whether it is a desktop app or a web app or something, to allow you to both view and edit would be helpful. Something like Protege for OWL, or like Top Parade Composer for SHACL. And I mean, depending on who funds my work, I may be able to develop such things. I've worked in that direction a little bit, but it's not something that I can make any promises about. I think that's, but it would be good to have.
Yeah, okay. Next question. How do you effectively test conformity to the standard when setting up a new BMS or sensor infrastructure?
I can take that one first. So the current workflow is to essentially execute a SHACL validator on your model. That is, and where that validator takes as input the model, which is your graph describing the building, as well as the relevant ontologies. That would be, in this case, Brick and RealEstateCore, as well as essentially specifications of the constraints you want that model to adhere to. If you just validate against the Brick and RealEstateCore ontologies, what you will get is whether or not you are using those ontologies correctly. If you are connecting something to something else that doesn't make physical sense, or you're putting a building inside a VAV box or something like that. And so those SHACL validators, because we're building on, so I'm speaking from the real estate, sorry, the RDF side. Because we're building on open standards, there are a number of open source and commercial platforms and products that will basically handle all of that validation for you. Where we are looking right now in Brick, and as part of my role with the National Renewable Energy Laboratory, is in encoding essentially application level constraints. If I want to execute a certain sequence of operations or run some fault detection rules, can I capture the semantic requirements in a way that can be understood by a SHACL validator? And so then I can go into my building and I say, well, I know I have 2 air handling units and 2 floors and 20 rooms on each floor and this many VAVs, and each of those VAVs should have this many points or these specific points. You can express that quite easily using SHACL, and those constraints can close over both Brick-related concepts as well as RealEstateCore-related concepts. And by virtue of that validation, you get a little report that says essentially what the delta is between the current version of the model and what the idealized form is as given by the specifications. And we are working on tooling that will be released hopefully by the end of the year that will assist in that authoring and validation process.
Okay, nice. Let's get to another question. Okay, great news that you're bringing Haystack along as well. Haystack harmonization was listed in the Brick roadmap, but will it then be harmonized with RealEstateCore 2 by extension? And also, does the Haystack harmonization roadmap have an initial schedule, not to take away from work you've already done with Brick and RealEstateCore? But as a consultant, I'm very much looking forward to being able to recommend the best of all worlds. Nice.
Yeah. So the high order bit here is the work to have an RDF-based model such as Brick or RealEstateCore work with a tag or document-based model like Haystack. The technical effort that goes into that should generalize across both of those ontologies. What specifically that's going to look like is still a matter of active development. So what I would say is it's a DOE project that's 3 years long. The first year of that does have harmonization as one of the things that we're working on. And part of that is some changes to Brick, some of that is changes to Project Haystack. I believe we will be speaking about the initial efforts at the Haystack Connect conference, which I think is in a couple weeks. So that's what I would look up. So I'll be speaking there about some of that integration effort. I believe Brian Frank from Haystack will be speaking about some of the effort that he's been doing on Project Haystack to help validate it and help ensure consistent usage of that model. Other than that, I would just be sort of pontificating or extrapolating beyond sort of initial prototypes. But the high order is yes.
Yeah. No, that makes sense. No problem. We've got like 5 minutes left of the webinar. Thanks everyone for the questions. It's been really good. I don't think I'm going to be able to get through everyone's questions, so sorry about that. But like, I'll take an easy one first, and then we'll see how many more we can fit in. Can you recommend a source where we can obtain basic knowledge on metadata standards like Brick, RealEstateCore? I guess, would that be the GitHub repositories and the websites? Anything to add to that?
I mean, there is a lot of material on the web on semantics. I mean, we can. There are master programs in universities that cover everything, and then there's shorter articles in Wikipedia and whatnot. I think on the RealEstateCore dev site, dev.realestatecore.io, there's an introductory text, very short. I think Brick, your text, Gabe, your texts are probably more extensive and well worked through. I've seen them, and so I'd say both of our project websites might be a good start. But then in addition to RealEstateCore and Brick, I mean, there's a whole bunch of semantic ontologies that cover roughly this area and that partly overlap or not. So we have the W3C SSN, Semantic Sensor Networks ontology. We have SAREF for Smart Appliances Reference ontology, I believe it is. We have the Linked Building Data Community Group bot ontology, which we are both sort of borrowing designs from for the spatial topology. And all of these have introductory text. And then there's IFC-OWL, of course. And so there's a bunch of different ontologies in this space, all of which have some introductory materials that are quite readable. But as a starting point, yeah, the RealEstateCore and the Brick websites, I would say. Or Gabe, is there any other starter materials that you could recommend?
Yes, I mean, it depends on what level you want to engage with the thing. We are building on years of work with years worth of reading you can do if that tickles your fancy. What I would recommend, so we've put some text for a sort of a developer-oriented perspective on Brick, docs.brickschema.org. So brickschema.org is you can find links to our community if you want to find our GitHub repository, sign up for the mailing list. There's also a docs site that's listed there. And we have some text that tries to bridge the gap between a software developer background and the RDF world. There are a couple of metadata schema review papers that have been written in recent years. There's a recent one from myself and Peter Powells, who's been involved with IFC-OWL and all of that. So that is available online through the Annex 81 International Energy Agency Investigation to Data-Driven Smart Buildings. There's also a fairly good one from Lawrence Berkeley National Labs, the scientist Marco Bertoni. If you look for a critical review of metadata ontologies or metadata schemas in buildings on Google Scholar, you can find that. And those are high-level overviews of how these ontologies all fit together and what perspectives on the building they model. Outside of that, yeah, I think Carl covered it.
Great. All right, that's really good. So some good resources there. Maybe we can include some links in the on the web page when we post the video as well. Yeah. Okay, so I think let's just take one more. I know we really ran out of time, but I think this is kind of like an interesting one because we're talking obviously about aligning these two standards. Brick sensor is modeled as a point, whereas rec sensor is modeled as a physical device. How are you planning to align such concepts?
Yeah. Oh, sorry. So as I said before, we're taking on the Brick points hierarchy. So what we are saying is, and the Brick equipment hierarchy. So if you want to express the physical device which is mounted in the ceiling or on the wall or what have you, it would be a Brick equipment that has a point which is the sensor point. RealEstateCore sensor is going away. At the moment, to the best of my knowledge, and Gabe, correct me if I'm wrong, these sort of sensor boxes, if you will, aren't actually something that exists under Brick equipment, but hopefully they'll be available there shortly, as you alluded to earlier.
Exactly. So the existing sort of information technology oriented classes we are going to be bringing under Brick, and so there will be a way of capturing the actual sensor platform as well as the I/O points presented on them.
Okay, great. Look, I'm sorry, there is a few outstanding questions there, but I guess you know, these guys are very approachable. So if you do have questions through email, go to the websites, get involved in the community, of course. And if you have things that you want to suggest to them about ways of developing or adding new things to these standards, then I'm sure they'd be happy to hear from you. Yeah, just remains for me to say thank you, everybody. I'll let Carl and Gabe have the final word.
Thanks. Yeah, do reach out to us. We have on the dev site, there's a link towards the bottom towards Gitter, and I think it's in the GitHub repo as well. And Gitter is a chat service that connects nicely with GitHub. And a lot of RealEstateCore community people are on there, and the devs are there, and I'm there. So if you have questions about RealEstateCore, hit us up on that chat or email or what have you. We're happy to take requests, questions, comments, etc.
Yeah, I'd just say we on bricksuma.org you can find links to our working groups, so you can come and chat with us, and we try to make sure those are US, Asia, and Europe and friendly. So I'll be up late waiting to talk Brick with all of you. We have a Google group mailing list that anyone is welcome to join and post, as well as GitHub issues. And I also do a terrible job of hiding my email address. So if you look around, you can find that. You can send me a note directly as well. And lastly, I just want to say it's really fantastic to work with such a gracious group of people that are willing to come together to really solve a really important problem. And I'm really proud of the work that we've done, and I'm really looking forward to how these kinds of collaborations can really help solve this kind of issue for a much bigger audience of people.
Thank you, Gabe. I mean, I can just mirror that. It's been great, and working with you guys has not only been technically great, but also a great, nice social experience.
Yes.
Perfect way to finish. Thank you so much for everyone for listening, and we'll say goodbye. Thanks a lot.